Okie dokie. According to my clock, it's 1 minute past. I think it's a good time to start now. Again, good morning, good afternoon, good evening, depending from where in the world you are connecting to this session. Welcome to this webinar about query performance for MySQL. My name is Carsten Thalheimer. I'm a solution engineer. I'm working out of Germany, close to Frankfurt. You probably have seen one of my sessions already. Today, I'm not alone. I do have quite a couple of people in the background. It's mainly Andrea and Mario. They are there to answer your questions. And please ask lots of very difficult questions. Give them a really hard time in the background. I will not follow the Q&A session this time. Again, we do have quite a couple of people attending this session, but Andrea and Mario are there. And again, please give them a hard time in answering the question. So, we will talk about MySQL and the short story here, right? So my wife is working in the pharma industry, and because of Corona, we're all working from home, and I very often see her watching some webinars as well. And yeah, they have this pharma industry slang, which is conflict of interest. And honestly speaking, in case that there is a doctor who's paid from a hospital XYZ, there is probably a conflict of interest for him. I don't know, but it's definitely for me. I do have a conflict of interest. I'm working for Oracle. I'm a fan of MySQL. So very sorry in case that I do not sing a praise song on other database technologies. We are really concentrating on MySQL in the session today. The agenda, it's mainly about MySQL best practices for MySQL on-premise and best practices for MySQL in the Oracle Cloud. And this is what we are going to do. We will talk a bit about MySQL, the status as of today. It's really just a quick one. Then we discuss hardware and operating systems underneath MySQL. We'll talk about the tuning and the best practices. We will see whether those rules can be applied for the MySQL database service. This is the cloud service offering from Oracle. We will talk about indexes and queries. And at the end, we will talk briefly about the MySQL HeatWave service, which is a real-time analytics engine for the MySQL database service. So let's start with the relevance of MySQL. Again, right, there are at least 10 different surveys. I'm usually just pointing to this one these days. This is a survey from 21 from Stack Overflow. I think more than 60, 70,000 people or something attended this survey, and they've been asked, right, so what database technology do you use for which database technology do you use for your application? And MySQL is ranking really, really good in this one, right, with kind of close to, I can't read the number, 50% or something. And this is not something new. This is the case since a couple of years. And this is really good for us. And a lot of people say, well, Stack Overflow, those are the individuals and so on and so forth. Again, I do not know, but even the professional developers, so people who consider themselves to be a professional, close to 50% are using MySQL. Even more interesting from my perspective is that most developers are not just using MySQL, but they are using different database technologies. So probably they're using MySQL in combination with, I don't know, with Redis, with Cassandra, probably with Mongo, probably with Microsoft, probably Postgres, probably Oracle. Again, I don't know. But generally speaking, MySQL is still very relevant these days. And just a short sidetrack here as well, right? So MySQL is not a new database technology. MySQL is around for more than 20 years. I think we celebrated 25 years of anniversary in 2020. So it is kind of established technology. So where we are today we are at the release MySQL 8. And we will talk about MySQL 8 and we will talk about a bit the release of MySQL 5.7 as well. Just a short hint here again, right? So when Oracle releases a MySQL product, it is usually available for 8 years. This means 5 years for premium support and 3 years for extended support. So MySQL 8 at the moment is in fact in a premium support state, and it will be supported until April 2026. So no worries here. The point what I want to make is that for MySQL 5.7, it's a bit different. So the release MySQL 5.7 is already in extended support state. It is still available until October 2023. Available means that until October next year, we will update the product, we will release bug fixes, we will release hot fixes, and so on and so forth, right? no issue here. But after October 2023, at least I'm not aware of, we are continuing supporting the release 5.7. So probably it's a good time in case that you're still using the release 5.7 to update to the latest and greatest, which in fact is the MySQL 8 product. Even so, when you consider using MySQL 5.7 further, and probably the same for all the releases of 5.5 or 5.6, we still support them. Don't get me wrong. So in case that you open a support ticket and you need help with the product, no problem here, right? So support will help you out. But in case that you hit a bug, which honestly speaking, after 8 years or something is kind of not likely, I would say, for example, for the release 5.5 or 5.6. But in case that you still hit a bug, we likely are not in the position to update or to provide hot fixes from a security or from a bug fix perspective anymore. So therefore, the release to be should be the release MySQL 8. And this is the starting point for talking about performance. So usually the newer MySQL releases are faster at scale. We do have plenty of those metrics, right, which you see here. When you go to mysql.com and you just go to the benchmarking section, right, there are various benchmarks available. The reality is the newer the MySQL product, the more or the better it scales at scale. Now, I am aware of a couple of benchmarks which are floating around in the internet, which basically says the release 5.7 is faster than MySQL. Honestly speaking, very often they are wrong. You have to compare apples with apples. And the default settings of the release 5.7 are different than the default settings of MySQL 8. So for example, MySQL 8 uses UTF-8 MB4, whereby MySQL 5.7 by default uses Latin 1. The same with the bin logs. By default, MySQL 8 is doing bin logging, whereby the MySQL 5.7 release by default is not doing bin logging. Same for security. By default, a lot of security options are switched off in the release 5.7, whereby most of the security options, or if not all, are enabled by default with the MySQL 8. So when you compare vanilla 5.7 and vanilla MySQL 8, sure, MySQL 5.7 will be faster, but in case that you do the equivalent from the other service, so you disable the release, you disable the security of MySQL 8, or you enable the security in release 5.7, you will see a complete different picture. There was a marketing slang when we brought out MySQL. I think it was MySQL 8 is twice as fast. Well, this is marketing. I'm not sure whether this is wrong or not, but definitely there is a huge impact, and very often, especially when you do have a couple of parallel connections and a lot of write load, the new products are the better one. And this is not just true for just the major release 5.7 and MySQL 8. This is very often also true for the minor releases of MySQL 8. We are more or less updating the MySQL 8 products, the same, by the way, for the release 5.7, more or less every 3 months. So the last release which we released was the release 8.0.27. Release 8.0.28. There is a typo. Sorry for this. Last week. And as part of this update, we are not just updating the latest and greatest bug fixes and security updates. We are very often also adding a couple of extra functionalities. This is not the full list. In case that you want to see the full list, which is in the product, you probably go to the release notes, which are mentioned on the top of the page, or you're going to the MySQL server team page, which unfortunately doesn't exist anymore. It's archived in the dev.mysql.com/blog archive log. It's a new link there, but still all the information is available. So when you want to see the full picture and every single piece and every single byte which we changed in, for example, 8.0.20, then please go to this blog archive and you will find the full information. And of course, there's also the release notes. And there are some really interesting things which we are bringing up as part of those updates. So for example, there is something in the release 8.0, where is it? Okay, I'm sorry, I don't see it, but somewhere there is the hash join. And hash join is something which we will discuss later on. This is something which we added in a later product of the MySQL 8 product. It wasn't there right from the beginning, but then again, right, so very often for the operation, there is a significant impact. Again, right, since last week, we do have the release 8.0.28. Again, there are, at least from my perspective, a couple of nice features, like, for example, you can do rename column instantly now. And for the global and for a session, you can allocate memory limits. Memory limits, we will talk about them later on as well. It's quite beneficial to somewhere limit the users so that in fact that there are extra users or new users coming into, right, they are not destroying the overall user experience of a server. So again, every update comes with security and bug fixes, and every updates come with a couple of additional features, and sometimes they are very, very beneficial for doing the MySQL operations. So we will talk about performance and a couple of general thoughts before we start, right? So first of all, performance of MySQL. Keep it simple and stupid, right? This is an acronym. I think it originally comes from the US Army or something, where they basically said, right, the more simple things are, the more likely they succeed successfully. And therefore, from a configuration perspective, again, right, keep the MyCNF, keep it simple. Try to understand what you are doing there. Don't inherit the variables from older releases or from rumors from the Google or from tuning wizard or something, right? Don't overdo it. Please, please, please restrict it to a couple of changes and do understand what you're doing there. We live in an agile world, so the settings which you've done in the release 5.7 are most likely not true for the release 8. Try to understand what you're doing. Very often I'm seeing values and variables in the MyCNF file, which basically are already depreciated or do not have any impact. It's just confusing. And when you ask the people, they very often said, right, I just did it as my previous colleague, or I read it in Google, or I read it somewhere else, right? This is usually not a good source. So try to understand what you're doing there. And in case that you do have a couple of MySQL systems, right? No two systems are the same. So very often you have a server for, I don't know, content management system, and then you probably have a server for IoT data. And obviously the use case is very different. MySQL can cope with both of them, but make sure that you understand what we are discussing from a variables perspective, and make sure to understand that it's probably different data. I will not go to the performance tuning section here. My point here is that in case that you're running the next Facebook, throughput is probably everything. But in case that you want to launch, I don't know, a rocket, probably the high availability is far more important for you than the throughput. And in case that you run a bank, the data safety, the data consistency is probably the main trigger for you. So again, right, depending on what you want to do, you have to tune your system. And this is not always regarding performance. Very often this is regarding security. Very often this is regarding disk I/O. We can talk about microservice and so on and so forth. So again, I will not go to this list. The point what I want to make here is we can only provide some guidelines and some pointers on what to think of, and then you have to adapt it for your needs. Again, not always performance tuning means the best performance. Just think microservice and smart DBs. Very often, right, the limit is, or the target is to limit the resource usage of MySQL for a given use case as well, which is obviously a bit different. So second slide about general thoughts. There is a huge discussion going on: bare metal versus virtualization versus container versus cloudland. Honestly speaking, from my perspective, I don't care. Very often this is a given. I cannot go to a customer and say, well, you have to go to container or you have to go to bare metal, right? This is a given. Every technology has advantages and disadvantages, and honestly speaking, just accept the challenge here. I cannot say run MySQL on bare metal because this is the best from a throughput perspective. Again, right, probably throughput isn't the main point for your environment, and therefore, right, probably containerland environments and smart DBs, that's what you need. The world is moving towards cloud. Again, a lot of people are using cloud already. Probably that's the challenge here. So therefore, right, there is no general yes, no statement here. But the second point, dedicated versus shared OS, right? Very, very often we do have services on an OS which are fighting for resources. So let's say there is an app and let's say there is a MySQL service. So in case that they both struggle with memory, right? What very often happens is that the MySQL service is taking over the memory, or the application is taking over the memory, which basically means, right, that you're short on memory, and at the end you do not know why. So therefore, right, I don't care whether it is bare metal, virtualization, or containerland, but please make sure that you use a dedicated OS for MySQL. In today's virtualization world or container world, right? This should not be a big thing. Have a dedicated environment for MySQL. That is really important. Then again, when you use the MySQL product, ideally, please use MySQL 8 if somehow possible, and make sure to use the latest. Do not use an old version. Yeah, I don't want to say you have to use the very latest, but use a recent version of MySQL. Because again, the greatest performance and the greatest improvements and technology come with the latest product. MySQL 8 is all about InnoDB, and in the following slides, we will really concentrate on just InnoDB. MyISAM is still there, but MyISAM is optional, and it is not recommended, but the reality is that still a lot of customers are using MyISAM. So I would like to say I'm just talking about InnoDB, but there are a couple of points where, in fact, I'm pointing to MyISAM as well, even so when our strong recommendation is to use InnoDB. Very often, the default values are good values, right? So we cannot tune everything as good values because we do not know the use case, we do not know the memory, we do not know the architecture, but very often the default valuables are good. There is one thing where you have to be a bit careful when you're updating MySQL. So let's assume you are using an old MySQL 5.5 version or something. You have to make sure to adopt the latest and greatest good values. So for example, there is something like InnoDB file per table setting, which has changed. I think it was in release 5.6 or 5.5. I even don't remember it. But then again, right, adopt the latest and greatest good value from MySQL 8, which basically means that, well, do the setting from scratch, set the values which you are aware of, and in case that you're not setting the value, in fact, we are referencing the default values from MySQL. When you do those changes, do one change at a time, do a restart of the MySQL. It should be a relatively small change, right? Leave the system up and running, validate it, monitor those changes. We will talk about the sys schema later on. Yeah, sometimes we need a bit of time, right? So the application needs to warm up first. You won't see an effect very often right after the beginning. But please, again, right, make sure rather small changes, or you know what you do a reboot, leave the application running, make sure that you have a measurement, whether this is Sysbench, whether this is monitoring. Somehow you have to validate whether the changes take an effect or does not take an effect. And of course, right, before you do any changes, make sure to understand what the implication of the change is and probably back up your data. In my following slides, I will use Oracle Linux 7.9. I will use it in the Oracle Cloud. This is basically, I'm using the infrastructure as a service. So this is the same as you would run MySQL in VMware or on-premise or whatever, right? You can, of course, use another operating system. You can use SUSE, you could use Windows, and so on and so forth. It's just that my examples are based on Oracle Linux and on the MySQL database service 8028 as well. So the hardware and the OS are underneath. So first of all, the CPU. Use fast and multi-core processors. In general, faster cores are very often significantly better in terms of SQL performance than a lot of cores, but slower, right? We will talk about this again a bit later during the MyCNF settings, but again, frequency, it's what very often counts when it comes up to single query execution. Hyperthreading. When you look at hyperthreading and databases in Google, you find at least 10 pages which mention, right, disable it, and you find at least 20 pages which say enable it, right? Our recommendation from a support perspective, I'm just, well, listening to what support says, is enable hyperthreading. Again, remember that old versions of MySQL did not scale that well in terms of CPU. So for example, the release 5.5 did not really scale above 16 vCPUs. Whereby MySQL 8, I think the limit is above 100, 105, 106 or something, right? Again, MySQL 8 rules. MySQL does support NUMA technology. NUMA is basically an architecture which spreads the memory across various cores, which means in turn that you are not using NUMA, you can end up in a situation that you are swapping the system, the OS is basically swapping the system because you're running on the wrong, let's call it the wrong core from an operating system perspective, and you do not get enough memory. So use NUMA technology, and again, we will configure this a bit later. You can control it with NUMA control -H. Monitor your CPUs and plan for more. Very often we start with low numbers of CPUs, but in reality, because of security, because of queries, very often we do need a bit more than initially planned. You are using top or HTOP. HTOP is the better tool probably here. It's more visualized from a user perspective. So make sure to monitor your CPUs on an OS level to understand what's going on, or use a monitoring tool. Memory. We will talk about InnoDB buffer in a second, but memory, MySQL loves memory, right? Ideally, the whole working set of your data, we are specifying the working set later on, should fit into memory, because let's face it, memory is still at least 1,000 times faster than even a fast SSD disk. So therefore, make sure to have enough memory. It doesn't make sense to run a multi-terabyte database on a VM with 1 CPU and 1 GB of memory. It probably does work, but it's most likely not that fast. And therefore, make sure to have enough memory. We will talk about this a bit more in depth. Add extra memory for the RAM, extra memory for the OS and for file system and for other related topics. So the calculation, right? So later on, we will calculate the OS with 3 GB as a starting point, right? So sometimes you can use more, sometimes you can use less. Let's start with 3. Then you've got the MySQL footprint, and the MySQL footprint is basically the InnoDB buffer plus you've got the connection-based settings. Again, plan for more. Calculate the memory and be aware that you probably need to adapt those changes. You can increase, you can decrease it. Again, we talk about this a bit later. The same goes for the disk, right? Hey, come on, what's going on here? Sorry, the same goes for the disk, right? Make sure to use low latency SSDs or use NVMe read. The reality again is very often MySQL is used in virtual environment and you do not really control the storage underneath. But in case that you can control it, well, the recommendation is to use at least fast one. For SSD disk, the recommendation is to use a InnoDB page file size of 4K. The default is 16K and you can only change it during the setup. It will have an impact on indexes. We will discuss this later on as well. But generally speaking, the more you are to the disk file page size, the slower MySQL, the faster MySQL is in terms of OLTP. So again, in case that you're looking for a lot of writes, a lot of OLTP load, probably you will see a benefit in using 4Ks over 16Ks, especially when you're using SSDs. In case that you're using a SAN or direct attached storage approach, XYZ or something, you probably leave everything as default. But in case that you really control the disk and you're really up for the latest and greatest, you can probably change this one. The same goes in case that you are having a physical disk, right? RAID 5 is very often chosen as a preferred solution because it somehow has the ideal part of in terms of scalability and in terms of availability. But then again, from a performance perspective, all this checksumming which takes place on the third disk from a RAID 5 system at the end is hurting the performance. So if somehow possible, use RAID 0.1 so you can stripe the disk and you can extend the disk size here if possible. Not all data from MySQL is depending on random writes. It's mainly the data there and it's mainly the undo logs which are depending on the randomize. In theory, you can put all the other logs like the logs, for example, from MySQL, like for example the binary logs and of course backups and so on other disks. The reality in my view is that most customers either they are on SSDs or they are not on SSDs. Splitting the individual files from a MySQL perspective, I've not seen it since a while, but technically it is possible. And if possible, use flash or battery backup either RAID systems or disk systems. Many storage solutions do provide these options, and it will significantly speed up the writings and the syncing of the data, because basically it's kept in a kind of a disk-based memory before it's written to disk. And given that it is controlled by dedicated battery or dedicated power consumption, right? The data is consistent even in case that you pull the cable. Again, plan for free space disk in case that you do a MySQL clone, in case that you're dumping data or you're storing data from a MySQL backup, for example, right? So very, very often, right, there should be a place somewhere at the disk where you have a bit of extra. Make sure to monitor your disk system, df-f or df-h, to make sure that you're not running out of disk space. This is still a very, very common support use case, running out of disk error, because yeah, let's face it, in case that you're running out of disks, then in fact the MySQL system will not work anymore. So the OS underneath MySQL, there again is a big discussion whether SUSE is better than Red Hat, and Red Hat is better than Oracle Linux, and Oracle Linux is better than Ubuntu, and Ubuntu is probably better than Debian. I don't know, right? And honestly speaking, I don't care. We are using Oracle Linux within Oracle because it's coming from Oracle. In reality, the world is using pretty much everything which is available, right? So the world seems to tend to Red Hat, but then again, in Germany, coming from Germany, SUSE is still big, and especially the open source gurus, right? They probably prefer Debian or Ubuntu. Honestly speaking, from MySQL perspective, we do support all of them. Please make sure to use a recent kernel. Please make sure to use a recent version, but beside of this one, that's good. Again, there is a big discussion whether X4 or XFS is better, right? Let's face it, sometimes X4 is better, sometimes XFS is better, depending on what you're doing and how you're doing it. But in my view, right, they are equally good. Use whatever you're familiar with. So whether this is XFS or X4, I really don't care. In case that you're setting up MySQL with the normal RPM or with normal YAM installation tooling, right, you probably do not have to care about U limits. But in case that you're setting up MySQL with a tarball-based installation, be aware that the default of the operating systems is 1024. When you have a lot of tables and when you have a lot of connections, you can run in limits here. And that's an issue, because then at a certain point, we first have to close down the connection to a particular file, and the user probably has to wait. So make sure to set the limits according to your needs. So set it to, I don't know, 10,000, 30,000, 50,000, 60,000, whatever you think is a good valuable here, but definitely the default is most likely wrong. You can, in case that you're using systemd, for example, very easily grep for the limits with the command which is mentioned here. You just PID the MySQL files and you search for the limits and check it out. By default, as far as I remember it, we are setting it as part of systemd to 10,000, which at least is 10 times the default of 1024. And therefore, right, this would be my recommendation as well, unless the error log of MySQL says something different and wants to have more. Swappiness, right? So when you think of what's happening in terms of caching, right? So MySQL is caching the data, the operating system is caching data, there is a swap file, and then we are bringing it to disk, and probably there is an own disk cache, right? There is a lot of swapping going on. And usually swapping is something good, but in terms of MySQL, and because of the amount of small data which we are sharing, very often this can really hurt us. And generally speaking, once we start not using the memory anymore, but we are using a disk-based swap, at the end, let's face it, MySQL is at risk to be killed, or at least it is incredibly slow. So therefore, make sure that the operating system does only the necessary swapping. Reduce the swappiness from an Linux perspective. You can do this with the command which is mentioned here, and please make sure to set it to 1, so make it as little as possible, but don't turn it off, because still, from a log perspective, for example, we sometimes rely on swapping the data. It's still better to have a slow system than to have an unstable system. So the recommendation, generally speaking, is to set the swappiness to 1. I think the default is 4 as far as I remember. I've not checked it for a while. That's something which you have to do. We can't do it as part of an RPM or YAM or whatever installation. So, and then there is a thing called OOM killer, out of memory killer. The idea here is from an operating system perspective that in case that you're running short of memory, and let's face it, the target is to be short on memory, because then you're using the system in an effective way, that the big services, the big processors, they are probably killed from the service out of memory. Now, the big service most likely is MySQL. So we are running short of memory. Probably the OS is killing the, well, most viable server, which is most likely MySQL, to make sure that the operating system continues to run. So something is wrong here. So therefore, make sure to make the out-of-memory score just as low as possible. From a MySQL perspective, I think the recommendation is 128. That's at least what the support paper says. But very often, I'm raising OOM score adjust to an even lower value of -1000. This basically means that the MySQL service, whatever happens, should not be killed unless it is absolutely necessary from a Linux perspective. That's basically the story here. And make sure to avoid file system caches from a Linux perspective. We do not want to be swapped from a MySQL perspective. That's something which you can do with a command which is called set inodb flush method equals o direct. That basically means that we are not using any swapping from a Linux perspective. And be aware that there is NUMA, and MySQL does support NUMA, but you have to configure it. This is not set by default. So make sure to set inodb NUMA interleave to 1. Later on, we have a kind of a summary of the MyCNF settings that's coming up there again, to make sure to leverage the underlying NUMA technology from an OS perspective. So far, that's the operating system. It shouldn't take too long, right? Probably just a couple of minutes. Make sure to report it so that other people can follow up what you've done here, and make sure that you are you're understanding what's happening basically at the end. And again, top and HTOP and DF and free, those are the technologies which you probably want to use to check whether the operating system underneath is running in a good mode. There are equivalent commands for Windows, there are equivalent commands for Mac, I'm sure, but again, right, we are concentrating on Oracle Linux. Let's come to the next point, which is the MySQL, the core MySQL server. So since MySQL 8, there are 2 files where you in fact can change the configuration of MySQL. The first one is the MyCNF. This is there forever, I think, right? At least for the release 5.1, 5.5, 5.6, 5.7 or something. So MyCNF, you basically specify where are the files, where is the log file, where is the data file, and so on and so forth. This is still there in MySQL 8. But once you start doing changes, and since MySQL 8, you can set those changes not just in MyCNF, you can also set a lot of the variables in the SQL session, and you can set them with either set persist or with reset persist. And the point is that once you set a variable in an SQL session, it is not stored in the MyCNF because that's validated, that's controlled from the operating system perspective, but it's also set in the MySQL auto. The MySQL auto CNF, it's usually stored in the same directory as the data directory, as the data files from InnoDB. And once you set a variable here, the variable is updated in the MySQL auto, which is basically a JSON update here. Quite comfortable. So when you want to validate what are the variables of MySQL, again, there are a couple of scenarios you can find it out. The most easy one is show variables like, and then you have an expression. So show variables like, I don't know, SSL, for example, or InnoDB or whatever, or you can directly reference the performance schema. First of all, the performance schema is significant faster, and from an overview perspective, it provides you a lot of extra information. So try it out, right? Just remember performance schema, global session variables, and probably variables by thread. Again, right, it's very often more straightforward to use the old way of show variables like something else. We talked about the MyCNF and we talked about the MySQL, the auto CNF, right? So where is a variable coming from? And there is a clever SQL statement which I just copied and pasted from the documentation. There is one thing which I changed at the end. You see that there is %. The original command was compiled, and I'm sure that you cannot read this data which is mentioned here. No worries. There is a bigger one, and I want to point to the section which is variable source. So where is a variable coming from? And there are a couple of options here. So there is the option compiled. Compiled basically means this is default value which was set during the configuration of MySQL. So when you start a MySQL configuration, right, as part of the compilation process, we grab a lot of variables, right? I think we have over 700 these days or something. So most of them are compiled. And then there is another option which is called global. Global basically means, well, this setting is coming from the myCNF setting. You can see it in the next column. It says /etc my.cnf. So this is a setting which is coming from the myCNF. And you can further down see a variable called dynamic. Dynamic, that is the variable which is coming from the MySQL, the auto CNF. So make sure to understand where a specific setting variable is coming from a MySQL perspective. And again, right, more generally speaking, there is the compiled option, which is the default. There's the global option with the myCNF, and there is a dynamic setting, which is coming from the MySQL, the auto. When we start MySQL, we first read the myCNF, then we read the MySQL, the auto, and yeah, in case that the user is setting a variable, then it's probably per session, or it is persisted in the MySQL, the auto CNF. So try to understand where a variable is coming from. So one of the most important variable which we are going to change is the MySQL dedicated server. This is not the default. This is not the default configuration of MySQL, even when I think it should be, but this is a different story. So I earlier said that my recommendation would be to use just MySQL on an environment, on an OS environment, and nothing else. And in case that it is really just MySQL on this server, then you can use this variable MySQL InnoDB dedicated server equals 1, which means that InnoDB is automatically configuring a couple of values based on the memory settings, which is recognized from MySQL. So for example, the InnoDB buffer, the log file size, the log files in group, and the flush method. So I said earlier on ODirect, right? We can recognize it, and as part of the operating system and as part of the available memory, we can adapt those values. In case that you're interested in how we are adopting those values, this gives an indication on, well, what we think should be the ideal solution. You can go to this link, the documentation of MySQL, and just check it out for InnoDB dedicated server, and right, and there we are doing the math depending on how much memory is available. It's 50%, it's 75%, and so on and so forth. And we are tuning those 4 variables. We probably will add a couple of more variables here in the future, but generally speaking, that's a good thing. But again, this is not ideal in case that you're running your application on the same MySQL, on the same operating system as the MySQL, because then you've got, again, the fight about memory and the fight about who is in charge of what. It probably doesn't work. But in case that you're running a dedicated environment, probably think about setting InnoDB dedicated server equals 1, and then all the hassle of the InnoDB buffer and so on and so forth is probably done automatically. You can still override those variables. So InnoDB buffer pool size, for example. So first of all, what is the InnoDB buffer? When you think of a read from a MySQL perspective, the InnoDB buffer, that's probably, think of a cache, right? So the data exists in the memory, and the data exists as well on the data. And as long as my queries or my output is referenced from the memory, it's rather quick. Once I have to do a disk file read, it's probably getting slower. So when I do a full table scan, for example, and the amount of data does not fit in memory, right? I'm reading the data from the memory and I'm reading the data from disk, which means this is probably slow. But let's assume that my full active working set, in fact, is coming from memory, then it's usually quite fast. Based on the previous slide, you remember that it says around 70 to 75 of the available memory. This is the biggest portion of the MySQL. This is probably the most important variable which you should use. In reality, what happens is that most customers said, well, I do have this server, 16 gigabytes, and they really don't look at what is the active data set. And there is a quite easy trick to find out whether it fits or whether it does not fit, right? When you look for the status of the InnoDB buffer pool pages and you concentrate on the free pages and on the total pages, right? And in case that you have about 20% or more free or available as part of the overall of the total pages, then it looks okay, right? So it basically means that the active data set, in fact, is in memory. Once this free variable is going to a lower number, consider even, well, adding more memory. And again, do the restart, because as part of the restart, the InnoDB dedicated server will probably increase the amount of the InnoDB buffer. By the way, that's a dynamic setting. You can even do it on a dynamic setting, but then again, you have to have the memory first. And based on this one, you can easily follow as a very rough indication whether the InnoDB buffer is big enough or not. This is the most important setting from an InnoDB perspective. I don't remember what the default is, whether it is still 8 or 16 megabytes again, but definitely most likely the default is wrong. In case that you have enough memory, make sure to use it. In case that you're using a SmartDB approach and you do not want to assign any InnoDB buffer, right? You can do this, but be aware that probably your disk I/O system is a bit busy at this point. Now, this is just reads. What about writes? So the InnoDB log buffer, the InnoDB log file size, think writes, right? So when you are sending something to MySQL, what basically happens is you're sending this data into the memory, and from a memory perspective, it is synced to the undo logs. And this is basically what is filling up at a given period in time. So the data consists or is living in the log file for a couple of seconds or a couple of minutes until the original changes are basically sent to the underlying file system, to the InnoDB storage engine. So again, the log file size needs to be big enough as well. In case that it is too small at a given period in time, you cannot write to the database anymore. Now, make it as big as you think it is okay. Again, I would do the configuration based on the files which I've done in my last slide again. Usually 512 megabytes, that's a starting point. There are 2 files, so it's a gigabyte. This is purely disk, so this is not that hurting that much. And I would not start with less than the amount. But again, it's set as part of the InnoDB dedicated server. So when we are writing to a MySQL perspective, right, then it usually the information is sent to the memory. From a memory, it is f-synced to the underlying undo logs. And usually, once you write something, we are doing the f-sync as part of the commit. Now, this means that the data is 100% ACID compliant. It is stored. Even when you pull the cable at a given period in time, even the data is committed or it's not committed. So the default is 1 and the default is ACID compliant. This is good. But this is very ineffective as well. It's probably better to wait for a couple of f-syncs first, let's say tens or hundreds, and then do all the f-sync in one go. From a write perspective, that is far more efficient. But then again, the issue here is that in case that you pull the power cable again, the information was just in memory, it was not f-synced to the redo logs, you lost the data. So therefore, usually a value of 1, this is default, means it is ACID compliance. But in case that you do not really lie 100% of your data, so for example, let's say Twitter, okay, in case that the server crashed, probably a user somewhere in the world has lost his Twitter blog, that's probably not a big thing. So therefore, you can probably go to switch to 0 or to 2, which basically means that you are delaying the f-syncs, which means it is faster. But in case that there is a crash, you can probably lose the data. So it improves your write speed, but you may lose the data. So make sure to understand this environment. I'm coming back to this because, again, when you look at MySQL tuning in Google, that's probably the first one which you're adding up. So the connections, right? The default is 151. Now, is this a good value? Is this a bad value? Well, it depends, right? So when you do show label status, you can see the max used connection. And what I would recommend here is look at the max, trace the max used connection and probably add a buffer 10%, 20% or something and restrict it at this level. Because in case that you have too many users connecting to the system, let's face it, you will run out of memory, which means that even the first 100 users probably will have a performance issue there as well. The connections, they are basically eating up the virtual CPU. They are eating up the CPU power. Again, in the slide, you have the link to MySQL connection handling. That's a link from a person, from a developer, Gear, who basically recommend about 4 to 8 connections per core. I'm not that conservative. I would say it's probably even more, and it depends, of course, on the query itself. So probably it's more in the area of 10 to 15, I would say, but there is no general yes, no statement. Be aware, virtual CPUs, especially when it comes up to encrypting the data or doing compression, for example, for the bin logs, right? CPU is a very important thing. In case that you're using the MySQL Enterprise Edition, there is a thing called the MySQL thread pool. This basically means this is a kind of proxy, which is proxying the connections towards the MySQL, the core MySQL service, which means at the end with the MySQL thread pool boxing, you can have an even higher number of active connections, and the thread pool is just coordinating the access to the InnoDB engine. So earlier on, I said 151. Is this a good number, right? Be aware. Look at the look at the picture at the top, right? There is a global setting like the InnoDB buffer, for example, and there are also per user, per connection settings. Per connection settings are, for example, read buffer, join buffer, sort buffer, and so on and so forth. You have to add a bit of extra here, but generally speaking, whenever there is a connection going on to the MySQL system, we are consuming some extra memory. Now, you remember we said 151 earlier on. Well, let's do the math shortly. So we have a system. In this case, it is 32 gigabytes of memory. We should calculate about 3 gigabytes for the operating system. We should calculate 75%, this is the general rule, of InnoDB buffer, plus again, 10% of overhead, so about 26, 27 gigabytes. The temp table, it's since, what was it, 16, 8016 or 17, again, I don't remember, but there is a general value for the overall usage of the temp table. And this is set to 1 gigabyte. You can again tune it. The default is 1 gigabyte. And we can't forget about all the log buffer size and so on and so forth, memory engine. It's not relevant here, which means that from our 32 gigabytes, again, 26, 27 gigabytes are stored from or are required from InnoDB. 1 gigabyte is planned for the temporary table, and 3 gigabyte is available for the operating system, which means out of the 32 gigabytes, you probably have 1.5 gigabytes for the connection. There's a general rule of thumb. Yeah, don't overdo it. Don't do more than 90%. Yeah, we are already short on memory with this system. You probably want to adapt the InnoDB buffer size, and you probably want to make it a bit bigger, a bit smaller, so that you have a bit more memory for the incoming connection. But this very clearly shows that the number of connections which are coming on, it's not unlimited. So make sure that the 151, whether this is a good or bad number, depends on your use case, that it really fits, because in case that you're overdoing it and you're using too much memory, there is an impact on all existing users. And this is something which you would like to avoid. The transaction isolation level, right? Again, by default, MySQL is repeatable read, which is quite conservative, which is database thinking quite good. But then again, when you think of a content management system, is this really required? Most likely not. Probably read committed is good as well. And by the way, the Oracle database does read commit by default as well. So stricter isolation typically means less concurrency, as you're probably using more logs, which means on the other side, in case that you're relaxing the isolation, there are less logs, which basically means that, again, when you want to write to the data, it will probably have a positive impact. Now, sounds far simpler than it is at the end. Please think with your application vendor, please think with your development colleagues whether this is an option to go or not. But then again, it is very, very often these days, and especially when it comes up to writing the data, it's quite easy and it's quite efficient to do. So other parameters which probably are relevant for you. I already mentioned InnoDB page size, right? So 4K, the default is 16K. In case that you're using SSDs and you're really using local disk and you're not relying on sound storage, think about changing it. InnoDB NUMA interleave, right? In case that you have a beefy server, right? Think about enabling it on the OS level. Normally it's done as part of the default setup. Think about, well, enabling it on the virtualization level, and think about, well, switching it on from a MySQL perspective. In case that you're still using MyISAM, which hopefully you do not do, but there is a key buffer size. The key buffer size, the general rule was 30% of the memory in the past, but again, right, whether this is really accurate or not, well, give it a try. Trial and error is probably your friend here, right? But generally speaking, try to migrate your data from MyISAM to InnoDB. Bin logging, right? Bin logging is a good thing. When you require replication or clustering or point-in-time recovery, great. You need it, perfect. But in case that you do not replication and you do not clustering and you probably don't rely on point-in-time recovery, that's probably an overkill. You can probably disable it in MySQL 8 and it will relax your system from disk I/O. There is another variable which is called InnoDB log writer threads. This is the behavior of MySQL 5.7. In case that you just have a couple of parallel writes to the system, you can simply point them to one single thread and not to multiple threads, which means as well for a low number of writes, this will increase the throughput when it comes up to writes. In case that you have a lot of parallel writes, so let's say more than 5 to 10 writers, you can probably leave the default, which means that you're having multiple threads controlling on what happens on the redo undo locking space. You probably want to make sure that going forward, customers or developers are not using MyISAM anymore. Yeah, disable them. Primary keys is a good thing to have. We will talk about primary keys in a second, but make sure that the customers use them. Whatever you do from a MySQL perspective, that MySQL is a critical component. Make sure to monitor the system, right? There are tools like the Enterprise Monitor, like Grafana, like Nagios, like Zabbix, like Prometheus. But the reality is that I'm a big fan of the sys schema. We will talk about the sys schema in a second. This is the internal performance schema matrix or internal performance schema, which are already pre-configured or pre-queried so that you can easily read them. Again, we are coming back to them in a second, but whatever you do with your MySQL environment, make sure that you do the monitoring of your system accordingly. Before we go to the query tuning, a couple of words on the MySQL database service and how the cloud probably simplifies your life. So Oracle is big in the cloud these days. We do have more than 30 data centers around the world. I'm not exactly sure whether this picture is still true or not. Again, we are opening a data center probably once a month these days. Again, I'm not 100% sure whether it is accurate. But then again, beside of China and beside of Russia, I would say that MySQL is probably, that the Oracle Cloud is probably around everywhere in the world as well. We are probably lacking a bit in the North African region, but then again, right, there is Jeddah already available. The MySQL database service is available in all of those data centers, and the MySQL database service is a full managed MySQL service. It's very easy to use, right? We are using the latest and greatest Oracle Cloud infrastructure too, with the combination of MySQL 8 and with the latest MySQL 8 product as well, 28. You can use 27 or you can use 28. It's 100% developed and managed from the MySQL team, and it includes the MySQL support. And you can go from very small, it starts from 1 OCPU up to 64 OCPUs and to a terabyte of data. There are various options available. High availability is available. MySQL HeatWave is available, and it usually starts at around about $43, 40 euros, something like this. The big benefit here is that we are taking responsibility for provisioning of the installation. So everything what I said earlier on with out of memory, with the swapping, you can simply forget it, right? That's basically something which we, from an Oracle perspective, are doing. We are also in charge of doing the regular backups. Again, you specify the time frame for this, of course, right? In case that you go for the HA option, right, we are responsible that the service is there. So it very much simplifies the environment. Everything what we discussed previously, basically you don't have to care about this anymore because we are doing it. You can still interact with the system at a certain level, but the majority of the systems, in fact, are done from an Oracle perspective. The queries itself, the database schema, the modeling, the users, query design, query optimization, reading the performance schema, reading the sys schema, right? This is still your responsibility. But then again, as part of the service, we do offer the support from MOS, from the Oracle support as well. Again, this is done by the MySQL team. So the installation of MySQL in the cloud is really simple, right? Again, you can configure a MyCNF, you can change certain variables in the configuration section. You provide a username, you specify whether it should be high available or whether you want to run the HeatWave environment or not. You specify a username and a password. You specify where it should run. You specify the size and the disk size. You specify the maintenance time. You specify the backup. And there you are. About 3, 4, 5 minutes later, you have a MySQL system up and running. You can still change certain things afterwards. So for example, I can still enable high availability. I can still add more disk space. I can still change my backup. I can still change my maintenance period, but you probably got it, right? It's very, very simple to use without being a MySQL expert, but still SQL, that is quite important for even the MySQL database service. And this is the next topic which I want to talk about. So indexes and query considerations. So the reality is that you can tune your system as good as you want to. Myself and users are always better in creating bad queries so that the system behaves slow. That's simply a fact, right? Just think about it. Everybody can write bad queries. Writing good queries is a bit more complex. And this is basically where the performance is coming from. So even on a very fast system, right, a bad query is a bad query. It's as simple as that. So general design rules, right? So again, we already talked about InnoDB. Don't want to go into detail here. All tables should have a primary and a specified primary key. Whether using int or big int in combination with outprint, it's not that relevant here, but make sure to have a simple primary key. That is the key message. And this is even more true when you're replicating or when you're using MySQL InnoDB cluster. For MySQL InnoDB cluster, it's mandatory to have a primary key. And this is also true for low cardinality. So some users do have very small table, right? Just a flag, for example. Still, we need a primary key because if not, probably InnoDB cluster will not work. Pick the right character set. So Latin 1 is usually significantly faster than UTF-8, but the point is people like smileys and they like icons and they like UTF-8. So therefore, very often it's mandated from a technology perspective. Again, Latin 1 is a bit more effective. So therefore, it's a trade-off between performance and usability. Correct data types. Yeah, make sure that not all columns are varchar 225, right? It doesn't really make sense. And in case that you're using JSON, make sure to really store it in JSON and not in text or in other field formats, right? It doesn't make sense. JSON is very significant faster. Foreign keys is, in case that you need it, that's probably coming from other database technologies. Yeah, you have to use it. But then again, from a performance perspective, it's probably not ideal. Query tuning itself, right? So identify the slow queries, right? Do the explain on the query, tune your query, and at the end, you should have a better query performance, right? Analyzing the queries. At the end, it's very simple, right? Get familiar with performance schema, but at least get familiar with the sys schema. This is really great. It is really, really simple to use, right? Just select star from XYZ, from session, from statement analysis, from process list, and you will see what's happening on the system. So this command, select star from sys.statement underscore analysis limit 3, limits the 3 most expensive in terms of latency, the most expensive queries. So forget about slow query logging or something, right? Really use the sys statement schema. Have a look at the other tables here as well. It's really straightforward. It's quite easy to use. It's built in in all MySQL 8 products. Use it. You can use it in the cloud. You can use it on premise as well. And in case that you recognize that there is a query which is probably slow, right? Use the explain. Explain basically asks your optimizer on how to do things, or use the explain analyze, which basically does the same, but it gives you the timing as well. And even low timings, right? In this case, 1.2 milliseconds. Just think about thousands of queries, right? It can end up in a significant cost. Make sure that you use the explain, make sure that you use explain analyze, try to understand why things are going wrong. And very often things are going wrong because of wrong indexing, right? An index is an extracted sorted value for a column. There is a compute cost, right? Again, don't overdo it. In case that you have too many indexes, this is bad as well. In case that you do not have an index and you need it, this is bad as well. So you have to have the right balance here. Keep your primary key as small as possible, and all secondary indexes will contain on the primary key. Again, the primary key, keep it as small as possible. And too many indexes will slow down the environment. I think I already said that the sys schema is a fantastic tool. There is a table for redundant indexes and there is a table for unused indexes. Use it, have a look at it, right? There are various tricks on how you can optimize the index. So for example, you can use prefix indexes. You can use compound indexes. In case that you're using compound indexes, right? Again, don't overdo it. Make sure to only store a primary key once. The optimizer, in most cases, will only use one index for table filtering. And again, in case that you want to filter for various variables, you probably have to use a combined index between this case with the user ID and a timestamp command. Complex SQL. Complex SQL is, yeah, it can happen, let's face it, but at the end, this is making things quite complicated. Do not do too much logic in the SQL, right? All intelligence should belong to the application. Sometimes denormalization is the way to queue. It is the way to go. Views cannot be persisted, and there is no index on the view. So very, very often, right, complex SQL is kind of the dead for a good performance. So what can you do then, right? So a short reminder, MySQL is a relational database. It is transactional, it is asset compliant, and so on and so forth. And it can do a couple of terabytes. That's not a big thing, but large MySQL instances comes with a cost, right? So usually the bigger the databases, the slower an insert or the slower a query will be. But what can you basically do when you have those complex queries and you have to do analytics or you have to do all up, right? From an on-premise perspective, you have to live with the performance which you have, add enough memory, add enough fast disks. From a cloud perspective, there is a simpler solution. From a cloud perspective, we do have a dedicated server, which is called MySQL Database Service. And this can very significantly simplify your life. So basically what happens is that you have your MySQL database and at some point it's getting too big. Let's say we're talking about a couple of terabytes and now you have to do analytics, right? And most likely it is getting a bit slow at this point. This is the concept of MySQL. What customers do is that they ETL the data to another database, and yeah, they do the analytics there. Again, this is what a lot of customers do. This is not ideal from our perspective, of course, right? The data extractions is putting a lot of load into MySQL. The data movement, well, is probably not secure. And most important, probably you are using stale data once it is on the other system. And of course, you have to look at multiple databases to manage. That's not what you want to do. So therefore, there is a new technology. It's only available in the cloud as of today, which means that it's a heatwave extension. When you look at the picture further down, it basically says that there is one single MySQL instance. Underneath, you've got the normal MySQL database, and we are syncing the data towards a heatwave backend. And this basically means that once a query is more expensive than a certain value, we are pushing the query to the backend. We are executing the query in the heatwave backend as well. So basically means heatwave is an OLTP and an OLAP engine. You don't have to change your data. The parser is unaltered, right? So from a client perspective, you're still using normal MySQL. It enables analytics for the MySQL data, and whether this is small or big data, it really doesn't matter because the heatwave backend scales up to 64 nodes in the backend equals 32 terabytes of data. Then again, it starts at $800, around about $30 for 3 MySQL heatwave instances, which is the smallest possible instance, and around a terabyte of data for MySQL. And it includes a technology which is called autopilot, which basically means that all the syncing of the data, which is running under the hood, it's done in an automatic way. It's quite easy to use. It's very simple to use at the end, and it's very automated as well. So because of timing, I'm going to skip those slides and I'm just going to the final version, which basically means you have your MySQL system. The MySQL system is putting data into MySQL. We are storing this normally on the InnoDB system. This is normal MySQL, nothing spectacular. In case that you're doing a query on this MySQL service and this query is hitting a certain threshold from an optimizer perspective, the query itself is not executed on InnoDB anymore, but it's pushed back to a so-called heatwave engine. The heatwave engine does have a copy of the data. You can specify which columns, which tables, which data you want to sync with the MySQL data. But the point is that the data, in fact, is at the end not stored in a raw-based format, as on the left side, but in fact, it's stored in a columnar format, which means as well that very often the query itself is significantly faster. The whole engine itself, heatwave engine, is storing the data in memory. In case that you're running out of memory, one server stores about 400 gigabytes of data. You can simply add more. You can simply add more servers up to 64. which equals about 30 terabytes of data. The data is automatically sharded across those servers. The data is automatically executed and stored in a columnar format. And in case that you got the query, it's pushing back the query to the MySQL environment, which on behalf of the HeatWave system is bringing it out to MySQL. Again, the whole parser, the whole SQL interface is normal, is vanilla MySQL. You can run all your applications without any changes, which means that when you run a HeatWave benchmark, this is just 40 gigabyte of DBCH data. It's rather simple. Look at the results. The left one is InnoDB, the right one is Rapid. The left one is in the area of about 400 seconds. Not sure whether this is the latest and greatest. We are optimizing the MySQL system with every single version, but on HeatWave, it's very significant faster, but it provides the same output. And this is the idea of HeatWave, right? It's a query acceleration tool, which because of the speed of the query can also care about significant bigger data than a normal MySQL InnoDB system. And this is not the worst case, right? The worst case is query number 9, which again, normally it's executed 1,800 seconds with InnoDB, and the query number 9 is executed in about 1.6 query. And again, right, you do not have to do major stuff here, right? You just enable this table to be analyzed from HeatWave, and everything else is normal MySQL, right? So you don't have to do things. This is the sweet thing, that is the nice thing with HeatWave. And basically what you can do, you can run very complex pictures, right? This is Oracle Analytics Cloud. You can run any other business intelligence or analytical tool here as well. And you can use MySQL for those kind of use cases as well. And it's speeding up the query. Again, you remember it from the last slide in a couple of 100 times, which means that we do not rely on caching methods like which are usually part of those analytical tools, but you can really directly link to the MySQL database. This is the benefit of HeatWave. It easily speeds up the query without you doing any query tuning. So I'm a bit late, I'm sorry for this, but I'm coming to my last slide. So in case that you want more information, there is plenty of more information, especially the blog from Dimitri. In case that you really want to dive into MySQL, some of the values and some of the statements which are provided early on are basically from Dimitri. Go to the blog, follow what he's doing. The same goes for Frederick Lefret, right? He's writing a lot of blogs, and you probably remember that at some of my slides, I pointed to his blogs because he's explaining it in a bit more detail, why you should use memory, why you should use the InnoDB buffer, why you should do certain things with the primary key. Again, it was part of the slides already. And of course, there is the documentation as well. So there we are at the end of the session. I hope that you had a lot of questions, that my colleagues are very, very busy in the background doing certain stuff. I just want to take a last minute for advocating the hands-on lab in case that you're interested. You can simply register. It's a free of charge training workshop, and we are doing the introduction into MySQL database service and HeatWave. You remember probably the benchmark which I showed you earlier on. I think it is part of this hands-on lab as well. Give it a try. As part of this, you get a $500 free voucher. You can use MySQL and MySQL HeatWave credits up to $500 for 30 days free of charge as well. Give it a try. Test out everything what I said early on. Thanks a lot for your attendance. And again, I hope that you had a lot of questions which you pushed to the back end. And that is the end of the session. I wish you a very nice remaining evening, remaining afternoon, or a nice day and a healthy remaining week. Thanks a lot, and bye-bye.